Hello my dear students, welcome to one more amazing session from Sri Chaitanya Academy. How are you all? Hi, programming channel. Hello, how are you all? So welcome to the session. आज हम चर्चा करने वाले हैं ये CBS examination preparation का जो content है complex compounds. The title is coordination compounds and you can also say it's a complex compounds. The most amazing chapter and the most important topic in the CBSE as well as in NEET examination. You are going to get 6 to 8 marks, minimum 6 marks from this particular chapter. You can expect 1 mark question, 2 marks question, 4 marks question as well from this chapter. So without delay, I want to take you to the all details of this particular chapter because it is a lengthy chapter. I want to give you 2 sessions today and tomorrow also. Today I will give you more emphasis on the basic terminologies and isomerism and nomenclature, and tomorrow I want to take you to the bonding in complexes and also applications of complexes. Definitely at any point simple question can be asked. Stick to the NCERT and do and all the best for your examination बच्चों. So नमस्कार नमस्कार नमस्कार. पढ़ाई कैसे चल रहा है बेटा? आपका नाम क्या? प्रोग्रामिंग चैनल आपका nickname दिया. So actual name I would be more comfortable in that. So those students who are online, please like the session and share with your friends and subscribe to Sri Chaitanya Academy NEET Infinity Learn YouTube channel. So that's fantastic. And in this complex compounds, this is the term itself is a complex, looks complex, and it is so implemented easily, and how you can do while you're practicing it. Take any complex, pick randomly any complex, you just count what I can say. Give the IUPAC name, give the structural isomer, give the stereoisomer, and find the primary valency, secondary valency, coordination number, hybridization, and you can apply magnetic moment, color, and crystal field splitting electronic configuration, and its stability. Total 10 parameters you can take it out. Isn't it? Hi Gopal. Now it is going to be a nice interaction between you and me. Bacho. So these 10 parameters, take any 10 complex, 5 complexes in a day. And moreover, these complexes you can pick it directly from the NCERT because घुमा के NCERT के examples से देते हैं. CBS examination में it is not that easy if you think big, and if you think simpler, it is that easy. So you can say it is easy as well as difficult. So without delay, you can go ahead with your complex compound. So far what we have done, we have completed the physical chemistry total aspect. We are into inorganic chemistry, and I will be completing organic chemistry in a stretch wise and the total organic chemistry conversions. Believe it or not, you follow these lectures till your examination, 70 out of 70 is your score in chemistry CBSE paper. And this explanation that what I am giving you in right now is going to be straight away, it can be helpful in preparation of NEET. So while the NEET examination preparation is going on, in the entire year when the board examination comes, you come with your lot of stress. So board mein likhna kaise? Okay, I'll come to that particular point. So when you write your board examination, that particular period, you will eventually leave your NEET examination preparation. Definitely, it's a phenomenal. So what I want to say, these sessions we are crafted, we tailored these sessions on the YouTube channel, both NEET examination content as well as CBSE examination content are parallelly going on. So you are nowhere detached to NEET examination preparation. Believe it or not, one thumbs up and fire emoji. Those who are there in the live, please like this session and share with your friends and subscribe to Sri Chaitanya Academy NEET YouTube channel. Right? Without delay, we shall start. And one important thing I want to address here. NEET examination question will be there, answers are visible, you know the concept, you can handle that question and you will visualize what is the correct option in that. But CBSE examination में presentation भी काफ़ी important है. If you write the correct answer at the end as a value or anything, you won't get full marks. You have to maintain the hierarchy in the presentation, and what is exactly the question is asking, what you need to be present. The presentation is very important, and Gopal, you follow these presentation skills and do it. And without delay, we talk about coordination compounds, the concepts and the basic terminologies pertaining to the complex compounds. Bacho, Save, right? Now let us see, these are the topics that you need to know, terminologies you need to know. So coordination entity, central metal ion, ligand, counter ions, coordination number. Simply you say very famous compound K4FeCN6. It's a complex compound, potassium ferrocyanide. And what is this? Let us identify this. Anything kept in the coordination sphere. So anything you keep in this square bracket is going to be coordination entity. So this is what is called as a coordination entity, right? And the D block elements that is present inside the square bracket is called central atom. It could be atom or ion. And the species which donate the electron pair to the central atom to form coordinate covalent bond is called as a ligand. And I am going to give you the list of ligands. And this is your counter ion. Anything outside the square bracket is going to be counter ion. And the number of ligands that are attached to the central atom is called as coordination number. So number of dative bonds that are present with the central atom is said to be coordination number. If it is a monodentate, it is going to be a coordination number. This number is going to be coordination number, right? Any doubt? So we'll do a coordination entity. A coordination entity is a constitutes a central metal atom along with the ligand. That is called as a coordination entity. And you can say here, central metal atom, the cation, which may be a neutral, okay, anions attached to the coordination covalent bond is called central atom. You can see here copper, here iron, here it is iron, or the coordination spheres, coordination central atom. It could be central atom you can say, or central metal ion you can say. So let us go ahead. Ligand, a species which can donate a lone pair of electron to the central atom and forms a coordinate covalent bond, a ligand, is said to be a ligand. Coordination covalent bond is also said to be a dative bond, bacho. And you can say number of ligating groups that is attached to the central atom is called as coordination number. Depending on number of ligands, number of donor atoms that are there in the ligand is said to be a monodentate, one dative bond can be formed. Bidentate, tridentate, tetradentate, hexadentate, EDT is an hexadentate. So that is called denticity. You can say sometimes a bidentate, you can also say it's a polydentate ligand. They can vary their denticity, said to be a flexidentate. And sometimes a ligand can have two donor atoms and only one atom can be donated at a time. Such are called ambidentate ligand. Like you can say cyanide, CN resonance में ऐसे आ सकते हैं आपका. So cyano, isocyano you can say. I'm fine, thank you. Life is chemistry, my life is chemistry, teaching chemistry. I want to be a teacher because of your beautiful students like you, right? A thumbs up, right? Okay, let us see. Based on the charge, ligand can be a neutral, ligand can be a cationic ligand, ligand can be a anionic ligand. Most of the cases we have either neutral ligand or mostly negative ligand. So positive ligands little not that frequent, okay. Most often you are going to get negative as well as a positive ligands. So coordination number काफी important चीज का है. Because of the coordination number only, we can just see what exactly the type of isomerism and its behavior. Bacho, here coordination number is the central metal atom, or the complex compound is the number of covalent coordinate bonds that is formed by the central atom. Now if you want to say CO, Cl6 3 minus. So based on this you can say coordination number is going to be 6. Okay? Then let us see CO C2 O4 thrice. It is going to be, coordination number is going to be 3 into 2 फिर भी 6 होगा. Sir, how it is? Because this is an oxalate ion. Oxalate ion is a bidentate ligand. So one oxalate ion can form 2 bonds. So that 3 oxalates together gives total 6 bonds. So coordination number 6 hoga. Understand? Clear? Fine. That's good. Fantastic. So these are the various coordination entities that I want to show you. Ligands, coordination number 6. Life is chemistry. आपका नाम क्या बेटा? So monodentate, ammonia, NH3, nitrogen is the donor atom. Whenever ammonia is there, IUPAC का हिसाब से you have to say ammonia, double M इस्तेमाल करना है, otherwise marks will be deducted. Water, it is known as aqua. Both spellings are correct. Symmetrical bidentate ligands, so halo, fluoro, chloro, bromo, iodo. Fluorido, chlorido, bromido, iodido, you can say. It is also say oxalate ion, ethylene diamine. Like that I want to show you various things. Ramesh, hi. One Gopal is there in today's class and one Ramesh is there in today's class. Bacho, come on. So the shape, coordination sphere. Depending upon the coordination number, the shape can be decided. If the coordination number is 2, it is a linear. 3, trigonal planar. 4, either tetrahedral or square planar you are going to see. Ramesh, you can see if it is 5 TGBP, trigonal bipyramidal, and if it is a 6, it is going to be of course octahedral. I want to say here among tetrahedral, square planar and octahedral, just these 3 are important as far as grade 11, 12th, 11 or NEET examination level is concerned. Fine, bacha? So this is a live interactive session. I request all the students to be more interactive to learn the concepts with us. Here we are not going to leave you at anyways. These sessions are absolutely free sessions on the YouTube. It's a live interactive session. You can talk to us and you can chat by using this chat box, and also if you have any concerns or any doubts, put in the comment box as well. If it is a live session, you can understand. If you don't have any time, you can watch the recording. Still, if you have a doubt, put in the comment box. Every day I am going to see that live sessions and recorded version. If the student has a doubt, I am going to reciprocate that. Okay, I am watching your video since 2 years. Classes so nice. Your God of Chemistry. Thank you very much, Ramesh. So you are watching my classes since last 2 years, but you are not maintaining a repo. Thank you very much. God bless you. Okay, अगर कुछ doubt है ना तो पूछना जल्दी. Make it fast. Right, moving ahead. So homoleptic and heteroleptic complexes. I mean to say complex in which the central atom is bound to only one kind of donor, one type of ligand is there, homoleptic. If more than one type of ligand is there, you can see, so 2 types of ligands are there, that is called heteroleptic complex. So the terminologies are very important, bacho. These terminologies can enhance the confidence level when you handle a question. That's why I want to give you elementary level from the scratch level of the concept. Bacho, Today we'll have a class, tomorrow also we have a class, so don't worry. I am going to tell you each and every point at maximum, so don't have to worry. Okay, Ramesh and Gopal. Right. And now mononuclear and polynuclear. Who is going to give the answer for this? Homonuclear and polynuclear. If the complex has only one central atom, that is called homonuclear. If the complex has more than one type of central atom, is called as a polynuclear beta. So you can say this is your mononuclear complex. If you can see, it is a polynuclear complex. Okay, so CO2, two cobalts are there. And you can see cationic, anionic, neutral complex. The charge on the complex makes it is. When you talk about in the complex compound, the complex ion can be cation, can be anion, can be neutral. When you consider this, CONH3 6Cl3, so 3 minus हटा देना, उसको आएगा 3 plus, so cationic complex. So the total complex is going to be cationic. And K4FeCN6, 4 plus निकाल दो, 4 minus आएगा, so it is going to be anionic complex. It's a neutral complex. Metal complexes are neutral. Metal carbonyls are neutral complex. You can see this is also neutral complex. So if you understand this, the IUPAC nomenclature, you need to change the central atom name based on the charge on the complex. So that makes a lot of importance here. So cationic and anionic neutral complex. अगर कुछ doubt है ना तो जल्दी बताओ, जल्दी जल्दी बताओ. Waiting for your doubts बच्चों. Moving ahead, which of the following represents the chelating ligand? What is the chelation? Somebody tell me what is the chelation? I want to say the answer for this is going to be oxalate, C2O4, H2C2O4, oxalic acid, 2Hu plus, that is given to C2O4 2 minus. So this is called oxalate ion. इसका structure आएगा आपका if you take this is a metal, it is going to form, yes it is. So if a polydentate ligand forms a ring like a structure, the ring size you can see 1, 2, 3, 4, 5. It may form 5-membered ring or 6-membered ring, and this formation of a ring is called chelation, and due to chelation it is going to extra stabilized. So because of the chelation, this ring is going to get extra stability. This is what is called as a chelate effect. 2 marks question or 1 marks question in CBSE examination. So I want to say this is going to be oxalate C2O4 2 minus. इसका ऑब्जर्वेशन आता है OX2 minus. Okay, ring is formed. कुछ डाउट है? Now और एक चीज है आपका number of EDTA molecule required to make an octahedral complex with Ca2 plus. Ca2 plus octahedral होने के लिए 6 bonds are required. EDTA is hexadentate ligand. So it can form, one EDTA can form 6 bonds, so that it is going to be 1 is enough. EDTA का structure पता है, ethylene diamine tetraacetate. What is ethylene? This is your methylene, right? Learning the structures are important, and it is going to be ethylene. methylene and ethylene, 2 carbons are there, ethylene. And diamine, so you are going to have 2 amino groups. And 4 acetate ions are there, CH2COO minus, CH2COO minus, and it is going to be CH2COO minus and CH2COO minus. Beta, I want to show what exactly the meaning of this. I can present a prepared slide, I can show it. बट आप खुद ही लिखना EDTA स्ट्रक्चर CBS एग्जामिनेशन में 1 मार्क का क्वेश्चन आ सकता है. अगर नीट एग्जामिनेशन में जा सकता है तो कितना डोनर एटम्स हैं. सो ऑक्सीजन इज अ डोनर एटम, it can form additive bond, it can form additive bond, it can form additive bond, it can form additive bond. And nitrogen is also a additive bond, it can also form additive bond. Total 6 additive bonds are there. मैं क्या बोलना चाहता हूँ, नाइट्रोजन डोनर्स are 2, oxygen donors are going to be 4, total is going to be 6. So it is going to be hexadentate, it can form octahedral complex. समझ में आ रही है बेटा बच्चों? So every point is important. I am explaining these points. That's good. Now let us see one more, naming the mononuclear compounds. Whenever IUPAC nomenclature, the mononuclear complexes we will have to learn. So based on this coordination entity, it could be negative charged, it could be positive charged, it could be neutral. Whatever you can see, first cationic part is named, then anionic part is named. And according to IUPAC recommendation, when you write a cationic part and anionic part, the complex could be at anionic part or a cationic part. First we have to give the name of the ligand, followed by the central atom, metal atom, and immediately after central metal atom you have to keep a bracket, parenthesis, and iska oxidation state bhi dena hai, right? So that is the best way. And the name of the complex, the ligand, are named alphabetical order before the name of the central atom. And also oxidation state of the metal, cation or anion, neutral coordination should be given in the Roman numeral kept in the parenthesis beta. And the name of the anionic ligand end with O, but the name of the positive ligand end with IUM. Neutral ligands have their names either in uncharged or have the characteristics names. Like these are the, just before theory we want to jump into the examples better. Prefixes like di, tri, tetra, penta, etc. is used to indicate the number of individual ligands in the coordination entity. And when the name of the ligand include numerical prefix, then the term di become bis, tri become tris, tetra become tetrakis, has to be used. So I'll come with an example here, just hold on here, शुरुआत से इतना complex नहीं करना है. And you can see if the complex ion is cation, the metal name is the same as the element. Iron become iron, copper become copper. When the name, for example, when the name is a anionic complex, you have to change the name of the central atom, like iron become a ferrate, nickel become nickelate, copper become cuprate, silver become argentate, zinc become zincate, right? So here it is given as an example. So please ask any doubts, bachcho. Now let us see the ligands and the name fluorido, chlorido, bromido, iodido, hydrido. In that everything is required, it may not be. Glycinato is required, iodido, bromido, chlorido, fluorido is required, thiocyanato is required, isothiocyanato, cyano, carbonato, nitrito, and acetato, oxalato, like this. Okay, so not everything is that rushing towards by hiding the things, bacho. And in that, positive ions are they rare, they are nitrosonium, that's just two are required. Just two are required, because if you open a textbook, dump of examples will be given, isn't it? Right? H2O, aqua, ammonia, amine, so double M is required. So, दिखाई दे रहा है क्या? Double M is required. Pyridine, carbonyl, ethane 1,2-diamine, and like that. Gopal and Ramesh. Now moving ahead, there is no need to indicate the number of counter ions with the number of prefixes with the name of the ionic complexes. You want to say K4 FeCN6, it is potassium hexa cyanoferrate, oxidation state is 2. Bas. Why ferrate? Because it's an anionic complex, isn't it? You need not have to write tetrapotassium. For the neutral complex molecule named as similar to that of cationic complex. NiCO4. tetracarbonyl निकल इन द मेटल कार्बोनाइल सिनर्जिक इफेक्ट के हिसाब से इसका ऑक्सीडेंट स्टेट 0 होगा. एनी डाउट? कुछ भी ना कुछ डाउट पूछना पड़ता. ओके, सो टेल मी अगले एग्जामिनेशन के आपका CPX एग्जामिनेशन पैटर्न. I think physics exam is supposed to be commenced on 19th, isn't it? How we are doing? After physics exam, definitely we will be jumping into the chemistry preparation rigorously and day and night. So physics का करना है अच्छा होगा. Okay, so stick to the physics teacher instruction. I don't want to indulge any in that. But when it comes to the chemistry, make a plan, make a cheat sheet and prepare well. अच्छा सोचो, अच्छा होगा. Okay, keep your confidence level always high, and don't be too confident, overconfident, and be enough confident, and never comes your pressure into the mind, so pressure can decrease your abilities, right? So take care of your health, stay healthy, and drink enough water, and maintain your daily routine in such a way that in the examination the pressure should not be there in the mind, isn't it? Fine. So moving ahead, write the formula of the following compounds. You can write amine, bromido, chlorido, nitrito O, platinum 2 ion. Dichlorido बीसीथेन 1,2-diamine, platinum 4 nitrate. So counter ion में nitrate आना पड़ा था. Diaqua, tetrahydroxo, aluminate 3. Mercury 1, tetrathiocyanato cobaltate 3. Who is going to give the answer for the first one? I am waiting for your answer in the chat box. Come on. So let us see. Amine, NH3, bromido, chlorido, nitrito O, ONO. Nitrito N means you can say NO2. Nitrito O means ONO. It is an ambidentate ligand. So platinum. So platinum का oxidation state 2 होगा. Okay, ion. So 0, -1, it is -1. So it is going to be -1. The answer comes like this. You can see the same thing. And similarly, Dichloridobis, ethane 1,2 diamine, platinum 4 nitrate, counter ion charge balance होने के लिए. And similarly 2 water is there, diaqua tetrahydroxo aluminate 3. And moving ahead, what is the formula of hexaamine chromium 3 hexacyanocobaltate 3 coordination compound? Just I am waiting for your answer in the chat box. Come on, I am watching your chat box. Give me the answer. Come on. In this you can say CrNH36 and COCN6. The charge will be automatically balanced. You know? So we'll go into the more details. Isomerism in coordination compounds. Come on, let's be active in the class. The isomerism compounds has the same molecular formula but differ in their structures, differ in their properties, are called isomers, and the phenomena is known as isomerism. Just like organic chemistry, in the complex compounds also, compounds will have isomerism. It can have two types of isomerism, structural isomerism and stereoisomerism. Compounds has, so I think it is visible, right? Structural isomerism. It is a structural isomerism. It has to be written this. Structural isomerism. And it is going to be stereoisomerism. So this particular structural isomerism, you have ionization isomerism, you have solvate isomerism, you have linkage isomerism, you have coordinate isomerism. And in the stereoisomerism, you have geometrical isomerism, you have optical isomerism. So we will be discussing all the parameters in today's class, and how the examination question comes also will be discussed. Stay tuned. Bacho, any doubt? If you have any specific doubt, please let us know. Here, students, let us talk about the structural isomerism. In that, first one is ionization isomerism. The isomerism arises due to the compounds have the same molecular formula, but when they dissolve in the water, they are going to furnish different ions, are called ionization isomers, and they are going to have this type of isomerism is possible when the counter ion of the complex salt itself, a potential ligand as well as the counter ion, they can displace here and there. So an example here, PTNH3Cl2 Br2 outside the square bracket, Br2 is outside the square bracket. Now you can say PTNH3 4 times Br2Cl2, Br2 is in outside inside the square bracket. So when you dissolve this in the water, you are going to get Br minus. When you dissolve this in the water, you are going to get Cl minus. So that can be tested by using excess silver nitrate. If you take silver nitrate into the action, so AgBr is going to be precipitated better. Here AgCl is going to be precipitated. So it is a white precipitate, it is going to be pale yellow precipitate. It is a white precipitate soluble in excess of ammonium hydroxide. It is sparingly soluble in excess of ammonium hydroxide. That is the way you can check the test for the solubility as well. And moving ahead, solvate isomerism. This is also an isomerism like ionization isomerism, but this time water is going to be the ligand. If the water is present inside the square bracket, you can say it is a ligand. If it is outside the square bracket, you can say it is a water of crystallization. And in this case, an example here, COH2O6, water molecules are there in the square bracket, Cl3 in the outside the square bracket. Now you can say COH2O5 Cl, Cl2 dot H2. So water is outside the square bracket, one molecule. So it appears gray green in color, but this complex appears violet in color. Please don't memorize the colors. I want to give you the demonstration how these complexes differ in its structure and its properties. So properties को difference दिखाने के लिए आपको ये colors indicate किया. Are you getting or not? NCERT में question दिया, and you will be given a complex, and you have to say which isomerism it is going to exhibit. You have to pick it. So that is going to be the catch point in the NEET examination. Children, hope you understand. So अगर कुछ doubt है ना तो जल्दी पूछना. Everything I am telling and teaching here with respect to NCERT textbook. बच्चों, if you have any doubts, please let me know. So moving ahead here, linkage isomerism. This linkage isomerism arises due to the bidentate ligand has a different donor atoms. So the different donor atoms can form different compounds. That is called linkage isomerism. Here you can say nitrito-O, nitrito-N, and cyano and isocyano comes under this category, you can see. In these two complexes, everything is same here, but here ONO is there, oxygen is the donor atom, NO2 is there, nitrogen is the donor atom. So the central atom is linked through nitrogen, the central atom is linked through oxygen. So this is what is called as coordination linkage isomerism. Fine. They differ in their properties better. Yes, absolutely they differ in their properties. Now coordination isomerism. This coordination isomerism is simple, looks complicated. It happens both cationic and anionic parts are complex entities. If you look into the example here, CONH36, CrCN6, this is a complex, and CrNH36, COCN6, this is another complex. Now could you spot out what is the difference? जो अमोनिया ना कोबाल्ट के साथ था, साइनाइड क्रोमियम के साथ एक कंपाउंड बन गया. अगर ये अमोनिया क्रोमियम के साथ होगा तो साइनाइड कोबाल्ट को साथ होगा तो this is going to give another complex. Are you getting or not? Any doubt? Fine. That's good. Now moving ahead, stereoisomerism. It's a super important and most complicated thing in the student's mind. बच्चों कुछ doubt है ना तो जल्दी बोलना. Waiting for your doubts. So the stereoisomers have the same chemical formula, same structure also, but they differ in the way the ligands are going to be attached to the central atom, and it has two versions. One is a geometrical isomerism, another one is optical isomerism. So you have cis and trans, very important noteworthy points I want to say. So bachcho, here in cis isomer similar ligands comes on the same side of the plane, trans isomer similar ligands comes in the opposite plane. In that geometrical isomerism, the compound with coordination number 4 and 6 are most important. Coordination number 4 का मतलब क्या? It is going to be tetrahedral, or it could be square planar. And coordination number 6 ka, it is going to be octahedral. It is going to be octahedral. Now let us see tetrahedral वालों को. Tetrahedral geometrical isomers दिखाई देंगे? Yes, it's a very important noteworthy point. Tetrahedral complex do not exhibit geometrical isomerism. Reason, 1 mark question, assertion and reasoning question, CBS examination, multiple choice question, NEET examination. So learn the concept and get the plausible score wherever it is there. Either it could be CBSE or NEET examination, bachcho. Look at this. Tetrahedral complex do not exhibit geometrical isomerism because the relative positions of the ligands attached to the central metal are the same with respect to each other. If you write these 2 lines in the CBS examination paper, 1 mark will be yours. So reasoning questions, NTA or CBSE, always try to get how much depth subject you know it. No. What is your understanding level? Everybody, if you have any doubts, please let me know. Come on. Moving ahead, however, square planar complex shows geometrical isomerism. Square planar complex, you can say, similar ligands are on the same side with respect to this chlorine. This is a cis isomer. You can also change this. The same thing, it can also be written, similar ligands are going to be in the cis. You can also take ammonia with respect to ammonia is also 6. When you talk, the similar ligands are on the opposite side, it is going to be a trans. It's a square planar complex. Find geometrical isomers of PTNHE3 twice in Cl2. You can say Ma2B2 will show square planar, will show geometrical isomerism. That is written in the coaching center material language. Here is the direct example. Any doubt? Bacho, come on. Keep writing along with me. Now moving ahead here, PTNHE3 twice BrNO2. So let's keep BrNO2 to the other side. So NHE3 twice 2 NHE3 is on the same side, square planar complex is cis. 2 NHE3s, you can just change the structure like this, both are same. While you take the ammonia in the opposite side, it is going to be, it is the trans isomer. Cis isomer and a trans isomer. Fine. Moving ahead here, square planar complexes containing unsymmetrical bidentate ligand MAB twice also show geometrical isomerism. If I show you some structure here, looks little complicated. So I will explain you this. This is called glycine. This is called glycine. So glycine ato, it is going to be NH2. So this is the structure it is shown. Oxygen is donating here, ammonia is donating, oxygen is donating, and nitrogen is donating. Here you can see 2 nitrogen donors on the same side or 2 oxygen donors on the same side. You can say it is cis isomer. So oxygens are opposite side, nitrogens are opposite side. This is going to be trans isomer. Fine. This is what is about the square planar complexes. Moving ahead, coming to the octahedral complex Ma4X2. Let us see the octahedral complex here. First of all, in this octahedral complex, so this is the octahedral complex like this. Position 1, so position 2, 3 and 4 and 5 and 6. So these are the ligand ka positions. When I want to say here transpositions, what are transpositions? 1 and 3 are transpositions, 2 and 4 are transpositions, and 5 and 6 are transpositions. Respective to what are the cis positions? So 1, 2 is a cis position, 1, 4 is a cis position, 4, 3 is a cis position, 2, 3 is a cis position. 5 with all 1, 2, 3, 4 are the cis position. 6 with all 1, 2, 3, 4 all are cis positions. Fine. So based on that you have to see this is a central atom. Based on that you have to visualize which is a cis, which is a trans. Fine. Expecting you to ask doubts. Now in this case, CO NH34 Cl2. In that 2 chlorines are on the same side. It is going to be cis isomer. 2 chlorines are in the opposite side. It is going to be a trans isomer. Cis isomer and trans isomer के बीच में you have the color variation also, violet and green. Don't memorize these colors. And I want to show you how to identify cis and trans. Now let's see here. COEN twice Cl2, it is going to be cis isomers and it is going to be trans isomer. Fine. Coordination number. What is EN? Somebody tell me in the chat box. Gopal, Ramesh, those students who are online, please like the session. Those who are watching this recording also can like the session. Bacho. Now moving ahead here, PT, PY twice pyridian and NH3 twice Cl2. You can take any two variables here. This is going to be cis and it is also cis. It is an optically active isomers. So what is optically active? So it is a D isomer, it is a L isomer. So this is both are cis only. Generally when it comes to octahedral complexes, most of the cases cis is going to be optically active. So compound can show optical activity if it has plane of polarizer light is going to be rotated by the complex or the compound. You have octahedral complexes, काफ़ी important है. They can have dextro-rotatory, they can have levo-rotatory. And dextro-levo-rotatory, which is dextro, which is levo, we can't say. But one is a plus isomer. If it is one is a plus isomer, इसका optical isomer minus isomer को होगा. And they are said to be pair of enantiomers. Enantiomers, non-superimposable mirror images and optically active compounds are said to be enantiomers, and they are also said to be pair of optical isomers are said to be enantiomers. Here it is a one example, PT, En twice and Cl2. Okay, both are cis isomers. Fine. And moving ahead here, complex of type MAA thrice and N plus can exhibit optical isomers, and COEN thrice 3 plus can show optical isomers, and they are mirror images to each other. Okay, one is a D dextro, another one is a levo, is a mirror image. And also the complexes with coordination number 6 can exhibit in octahedral geometry. And which of the following is an optical isomer? So you have to check the dissymmetry in its structure. Just I want to say here it's the structures, and it is going to be COEN thrice. That is the previous example. And I want to take some more things here. Werner's postulates. And I want to say one important thing here, FAC and mirror isomerism. FAC and facial and meridional. What is this facial and meridional? Let us see. CO NH3 thrice and Cl3. This complex can show FAC and MER isomers. It is the type of geometrical isomerism with octahedral complexes. And let us see this complex. CO in the octahedral system, CO in the octahedral system. You are going to see the similar ligands on the one side of the plane, NH3, you can say Cl, 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 NH3, NH3 and NH3. I want to say here Cl, Cl and Cl, NH3 and NH3 and NH3. So this is said to be fascial or FAC isomer because one phase of this octahedral system, you can say one phase of the octahedral system, similar ligands are seen. So we can say in the NCERT this example is given FAC. In the NCERT this example is given FAC. And you are going to see meridonial. In NCERT it is given as a MER, the abbreviation is going to be meridonial. This is a kind of geometrical isomerism. Okay. So which of the following complex compounds can show optical isomerism? Everything is included here. Okay. Anyways, Werner, there are various theories which you need to talk here. You have theories, Werner theory, you have valence bond theory and crystal field theory. These three theories we need to study in these complex compounds. आज के लिए थोड़ा सा Werner theory दिखाना चाहता हूँ. Postulates of Werner's theory. In compound coordination compounds, metal shows two types of variable valencies. One is a primary valency and a secondary valency. You know, primary valency is ionizable valency. Okay, and it is shown by dot dot dot, and it is equal to the oxidation state, and it is composed by, it is covered by counter ions. It has no direction. Talking about the secondary valencies, the secondary valencies, non-ionizable valencies, they are composed by dative bonds. So these are satisfied by the ligands, and it is equal to the coordination number, and in that the group bounded by the secondary linkage to the metal have the characteristic directions, so that have the spatial arrangement about the different coordination numbers. So has given, Werner further postulated that octahedral, tetrahedral, square planar geometrical shapes are more common in coordination compounds. Okay, and octahedral entities, tetrahedral complex and the square planar. So in this case, bachcho, example you can say CONH3, COCl3NH3. So Werner dissolved cobalt trichloride in ammonia and crystallized different compounds in the different properties. So different crystals with different colors are observed. They are said to be Werner series. Werner is said to be father of coordination compound, and he has given lot of things here. COCl3 6NH3 complex can be represented like the primary valence of cobalt is satisfied by 3 chlorines and the secondary valence is satisfied by the 6 NH3s. Coordination number is fixed, is not variable. Secondary valence is fixed, primary valence is not fixed. Fine. And you can say, so this is how it is shown. Bacho, effective atomic number and all we'll discuss. Tomorrow we will come across with valence bond theory, and we'll talk about crystal field theory and bonding in metal carbonyls and applications of complex compounds, and we'll do some basic examples based on that. Okay, आज के लिए इतने हैं. As time is almost exhausted, we can take a break and for today, and we'll join with more content for tomorrow. ठीक है, more content for tomorrow. आज के लिए इतना है बेटा. अगर कुछ डाउट है ना तो आप जल्दी चार्ट बॉक्स में फटाफट बोलना, so that we can have a beautiful discussion about that. Today I enjoyed class like anything because amazing students with amazing doubts. Gopal and Ramesh is there, and those students who are online, please like the session. Those students who are watching the recording, please like the session, share with your friends, and subscribe to Sri Chaitanya Academy Infinity Land NEET YouTube channel. And I am done for my side. Signing off, Dr. Suresh.